Hey folks, welcome back to PreCalc. So, you've already pre-read this circular function thing, and you might have had a bunch of questions. You might be confused. I'm here to tell you that this is a lot easier than it looks. All it is trig with radians. And you guys already have a leg up on this because you did it in Algebra 2. So, let's take a look. All this is going to be on delta math. So, you're going to do a delta math problem set where, given a graph, you're going to find the equation. Then you're going to do a second delta math problem set where you're going to be given some pertinent information, and you're going to find the equation. Let's take a look. So let's get some vocab out of the way first. This entire section of your textbook is on circular functions. However, you might be thinking, what the heck, we're doing trig, then we're doing radians, then we're doing circular functions. They're not related. Circular functions are trig functions. They're just another name for them. They're not using degrees, but rather they just use radians for it. Now the reason why we have a different name for them is because since radians have no unit with them, they can be used for real-world problems a lot easier, because then we can just assume that the unit's already there. For instance, I can just apply a unit to it. If I know every 2 days something happens, I can just apply it easily here in a real-world problem. I don't have to use a degree. Now, this is a pretty useful little chart between degrees and radians. If the phrase is trigonometric, it's degree. If the variable is theta, it's degree. If the symbol is a degree, well, it's a degree. If the phrase is circular, we're dealing with radians. If the variable is x, we're dealing with radians. If the symbol has none but uses pi, so for instance it has no symbol to indicate a unit, but it uses pi, it's radians. And here's what it's going to look like. We're going to figure out the equation of this trig graph. Now we've done the equations of trig graphs before, but they've been in degree, and I was a stickler about labeling the axes. You can see here that this axis has pi in it. However, there are no degree symbols, so this is going to be in radians. Everything else is going to be the exact same. There's going to be a midline, there's going to be a phase discrepancy, there's going to be all that good stuff. So, first things first, let's find out the midline and our amplitude. Well, halfway between 4 and -3 is 1, so this is going to be our midline. Our midline is +1. So we can then say, well, from the midline to the maximum, that's our amplitude. That's 4. So let's find one cycle. Now I'm looking at this and it's starting up here at the maximum. So this right here is one cycle of cosine. Remember, cosine starts at the max, sine starts at the min. Since it's starting here, my phase displacement is 0. There's no phase displacement. It already starts where it normally would. Now we just need to figure out our b value. So our b value is going to be given by this is 8 pi over 5, because that's when it ends its full cycle, divided by 2 pi. Or rather, this is the 1 over b value. So that's just going to be 8 pi over 5 times this. Our pi values are going to cancel. This is going to be 4, that's going to be 1. So we're left with 4 over 5. Now I stated that's 1 over b. Remember, you got to flip it. So b is equal to 5 over 4. Throwing all of this together, we can make our equation. Y is going to be equal to 1 plus the amplitude, which is going to be 4. The green is telling us that this is cosine. Blue is telling us that we have a b value of 5/4. And we have no phase displacement, so here we just put x. Again, we're dealing with radians, so it's x. There is no symbol here. Sometimes pi is included, sometimes it's not, and we're just using x. And we're done with this one. So let's check out how we can use Desmos to check our work with that first problem. I'm going to go over here and say, well, y is equal to 1 plus 4 cosine of 5/4 x. And we can see that it pops up here. Now, this might be really difficult to tell because these are going in terms of 1 unit. So you can go over here to your settings, and you can change the step right here. In our problem, we had 2 pi over 5 represent each one of those steps. In order to type pi in, I literally just typed pi, and typed in. Notice we're also in radians down here. And we can check here that this looks exactly like our delta math graph. It's happening exactly as we would want it to, so we know we're right. So this is what we can also have. We're going to write a sine function that has a midline of 2, an amplitude of 4, and a period of 8 pi. So again, really similar to what we've done. The only difference here is that's the same, and the period is no longer in terms of degrees, it's in terms of pi. That's what's telling us this is a circular function. Also, they tell us it's a sine function, so that's pretty helpful. Well, we can just write it out. Y is equal to, well, midline is 2, so that starts us off. Amplitude is 4, boom. They tell us it's a sine function. They don't say anything about a phase displacement, so I don't need to worry about it. I just need to figure out the period of 8 pi. So I can do 8 pi over 2 pi, and that's equal to 4 over 1, so 4. But remember, whatever's up here, you got to flip it, because we're inside the trig function. And we're dealing with radians, so I'm not going to put theta, I'm going to put x. That's my trig function, that's my circular function that has all of this stuff in here. If there was a phase displacement, it would be the exact same thing. We just add in a phase displacement, and that would normally involve pi. Great! You've seen how to do both of those things on Delta Math. Remember, you can always check on the useful Delta Math videos, and it'll help guide you through it. So, now, time to actually go and do the Delta Math. After that, you're going to complete the summary question, and then you're going to do the reading survey for the next section, which talks about inverse trig functions in terms of radians. Have a great day, folks. If you have questions, see me in office hours, read the textbook, ask a question in class, find a classmate, or check out the additional resources which I have provided. See ya!